for segments and circles, you'll notice that I called it segments and circles. On this page, write down everything you're going to be seeing on here is a length, it's a distance. You've got to separate all of your angle knowledge now and arc knowledge from this. We're not dealing in 180 degrees or 360 degrees. We're now looking at just lengths. I'm going to give you the rules today. I'm not going to show you where this is coming from, but eventually we'll do a proof of this. And once we figure out the rule, these three rules, you'll see that where it's coming from and how we're going to prove it is pretty obvious. Let's put 6 here, 4 here, 2 here, 12 here. These are not angles, these are not degree measures, these are not arcs. You know, in my other class, we decided on our own rules, a way to remember, and my other class decided on the phrase cross multiply. If you take the 6, multiply it by the 4, if you take the 2 and multiply it by the 12, you should get the same thing. So some people call this the chord pieces rule or chord pieces multiplication. Whatever you need to do to remember that you multiply the two parts of the chord. They called it cross multiply because that's what it looked like. You were doing that times that, you were doing that times that. When do we cross multiply usually? Proportions? Where did we use proportions the most in our past units? 30? Triangles? What kind of triangles? Congruent? Similar. So ultimately, when we do the proof of this, it's going to come from similar triangles. Do you see any triangles in the original figure? Could we make triangles in the original figure? Could we put lines there and there? That's what's going to eventually happen when we do the proof of this. For right now, you just need to know that when you see a situation with two chords and you've got pieces of chords and you have enough pieces or lengths to determine a missing piece like X, that the rule is set up an equation where you're cross multiplying with those pieces. So I'm going to do 9 times 8. I'm going to do 12 times X. That's 72 equal to 12X. Do a little division. X in this case would be 6. What is that? That is a distance. That is the length of that little chunk from here to here of that chord. And that's what I've got up on the sideboard. I've got a little segment area here. When you have two chords and you've got pieces of those chords, cross multiply those pieces to set up an equation. The rest of the rules deal with multiplication. And ultimately, they're going to come from similar triangles, even though we're not looking at similar triangles yet. If it's a tangent and a secant, and you've got distances, so let's put 9 here. That's this distance from this point to this point. And let's say that that's 27, and we'll put a 3 here. You've got to have certain pieces of information in order to do this. That 3 is the portion that's outside the circle, so I'm going to designate that as O. This portion right here, what do we call this when it touches just once? That's the tangent. I'm going to put a T there. And we're going to call this distance from here all the way through to here, from this point to this point. That's the secant, and I'm going to designate that as, or define it as the whole. So from here to here, we'll call the whole. From here to here, we'll call the outer. Here's the rule. We call it the 2 rule. Take the tangent, square it. That's going to be equal to the whole length times the outer length. What is 9 squared? 81. What is 27 times 3? 81. That will always occur when you have a tangent secant situation and you're looking at distances and lengths. I'm giving you very simple examples right now. Eventually, there's a lot of variations. Maybe you're looking for the tangent. Maybe you're looking for the outer portion. Maybe you're looking for the inner portion. Maybe you're looking for the whole portion. Every problem's a little bit different. For our example, put an 8 out here. Put a 2 here. This time we're going to be looking for which portion? The whole. X is designated as what we call the whole portion. If it helps, label. This is your tangent portion, this is your outer portion, this is your whole portion. What's the rule? The rule is the 2 rule. Not only does it spell out the word 2, but it has a 2 in it. So what's going to be squared? 8. 8 squared is equal to the whole times the outer. It doesn't really matter which order I put those 2 in, because I'm multiplying them. We're going to have 2 times x. 64 equals 2x. X is equal to 32. What is that? That is this distance from here all the way to here that we've designated as the whole portion of the secant. It's a distance. Try to separate all of this from all of the angle and arc degree information that we've been looking at up until this point. That's the 2 rule. 2 secants. Touches twice. Since we don't have a tangent in this diagram, this is the whoa-whoa rule. Whole times outer, whole times outer. So it might look something like that. If I have all the pieces, the whole secant, which we're designating from here to here, times the outer portion. Outer portion's right here. That's going to be equal to the whole times the outer portion there. That's 8 times 3. We get 24 and 24. That's with everything being given to you. Once again, very simple examples right now. If you're looking at a two-secant situation, and all you have in front of you are distances, lengths, you know the rule is whoa, whole times outer, whole times outer. Do you have all those components? I've got a whole, I've got an outer. Whole, outer, I've got enough pieces that I'm going to be able to solve for x. 16 times 2, 4 times x. X is 8. 8 is this distance from here to here. All of the problems are just going to be variations on those rules. Maybe you'd have to find this distance right here. Well, that just involves a little bit of subtraction, because the 4 is part of this 8. This entire distance is 8. This portion of it from here to here is just 4. That's the last of the big rules. There's other little rules, but you already have them. They're on your circle terminology worksheet. You need to read that.